Now we calculate total energy. As we know, total energy is equals to kinetic energy plus potential energy. And how the potential energy and kinetic energy of system changes with time. As we know, energy is equals to kinetic energy plus potential energy. According to law of conservation, we know that total energy remains constant. So, total energy is equals to kinetic energy plus potential energy is equals to constant. Now we consider a spring that connected with a fixed point and having mass m. When it moves from mean position, it has some potential energy half kx square. According to simple harmonic motion and equation of displacement, and potential energy is equals to half k square cos square omega t plus phi. Now, as we know, potential energy is equals to half m omega square. As we know, k is equals omega is equals to under root km. So we derive value of k from this and put this in equation. Now we write kinetic energy when body moves covers some distance, then it has some velocity. To that velocity it have kinetic energy, that is equals to half mv square. Now we put the value of velocity of simple harmonic motion in equation, then we get kinetic energy is equals to half m omega square a square sine square omega t plus phi. If, as we know, energy is equals to sum of all the energy, so we write energy is equals to potential energy plus kinetic energy. Potential energy is our equation 1 and value of kinetic energy is our equation 2. Now we put equation 1 and 2 in this. We have energy is equals to half m omega square a square. And this is common in both terms, so we write half m omega square a square bracket cos square omega t plus phi plus sine square omega t plus phi. As we know by trigonometry identity that cos square alpha plus sine square alpha is equals to 1. So our equation becomes E is equals to half m omega square a square. As we know, omega is equals to under root k upon m. So if we simplify our equation, we get energy is equals to half kx square. Half k is square, sorry. Now, if we look at the figure that is given, we consider our case in different points, how our kinetic energy changes into potential energy and potential energy changes into kinetic energy. Look at point A. Point O is our equilibrium position and point A is our right extreme point and minus A is our left extreme point. This is graph between energy and amplitude. At point A, we have maximum potential energy. So we write potential energy is equal to half k square. Here at point A, and we have potential energy is equal to half k square cos square omega t plus phi. Now we discuss at that point what is kinetic energy. Here kinetic energy is 0. Total energy is only potential energy. At point O, we have potential energy that is 0, and all the energy is in the form of kinetic energy. Now we discuss our next position after writing that potential energy is 0 for position O, that is equilibrium position, and kinetic energy is half mv square, that is equals to half m omega square a square sine square omega t plus phi. As we know, at point O, bodies not remain or maintain its disposition, it moves towards negative way because it is ideal simple harmonic conditions where we consider we have zero resistance. So at negative A, body have again potential energy, that is because is half kx square. Now all the energy is in the form of potential energy, so we write half ka square here. And at this point we have kinetic energy 0. This is the basic values of energy that is given. Now we draw a graph between energy and amplitude. At point A, we have all the energy in the form of potential energy, and at that point kinetic energy is 0. Now at O, we have potential energy 0, but all the energy is in the form of kinetic energy. So we mark this. At minus A, we have all the energies in potential energy form, and kinetic energy at that point is 0. So we mark our value. Now we draw a graph, or we join points for kinetic energy and potential energy. Then we get the graph like that. This is the graph for our potential energy that is shown in dark color, and this is graph for our kinetic energy that is shown in light color. When we want to draw a graph for total energy, that is equals to sum of potential energy and kinetic energy, that is a straight line, means energy remains constant. That is shown in this figure. But if we show our arrow, that is shown that by using this graph, that kinetic energy plus potential energy is energy constant, that is proved by this graph. If we take sum of kinetic energy and potential energy, we get constant energy. Now we calculate velocity of simple harmonic motion by considering the equation of total energy. Now we have a spring that is connected with mass and other end is fixed. When the spring moves, it has some velocity, so we calculate this velocity. When we calculate this velocity, we have total energy is equals to kinetic energy plus potential energy. From previous equation, we have total energy half k a square and potential energy is half k x square. Kinetic energy is half mv square. When we solve this, we take half and divide the whole equation by m. So by solving this, we get value of velocity, that is plus minus